I really appreciate you keeping me on top of that because I forget like all the time. It's really bad. Yeah. And I think, let's see, yes, we are getting audio capture, so that's also exciting. Okay. So I just wanted to remind you that on our Teams, if you need to, like if you've missed anything or whatever, there are videos of our lessons. Okay, and they are here. And of course, we have September the 14th. I had the sound input set incorrectly, so there was no sound, so I did not post it because that seems sort of silly. But most of our lessons are up there if you need them. You should have gotten a notification about upcoming quizzes. I tried to be like, fairly descriptive in what is going to be on your quizzes. So those are in the upcoming quizzes and tests section. And I think I manage to get up your course outline? Let's see. I did. Huzzah. Okay. Should we take a quick look at it together? Do you care? Okay, let's take a quick look together. Just because I don't think we have we? No. Okay. La la la. Waiting. Okay. Okay, this is like, I sent this letter. You guys all should have gotten this in an email. Yes? So, did you read the email? No, okay, so we're gonna talk about it. Work with intent. Don't just try to finish quickly. Try to absorb the information. Work with the intent to learn. This is my advice for people to be successful. Communicate. Most problems and stresses can be minimized by communicating with me. So if a situation arises or if something isn't working for you, do let me know and we can deal with it together. I find people most often run into problems when they start hiding from their problems. Yes, I had a grade 9 student this morning who did not show up to write his requiz because he was feeling nervous about writing his requiz. And I'm like, dude, we could have practiced together. Like don't hide from your problems. Come and talk to me and I can help you out. Okay? Take charge of your own learning. Some of you are already doing this. This is fantastic. You get extra help when you need it. Do it right away. Don't wait for it. This class moves fairly quickly at some times, and well, for some people it won't, but for some people it will move quite quickly, so make sure you get that help right away. Use the answer key effectively. Some people like to copy the answer key. I don't think I've seen anyone doing that in here, but that would be a silly thing because you would get maybe a homework mark and then not do well on your quizzes or test. Proven study techniques. We've talked about spaced repetition. Have we talked about the Pomodoro method? Negative. Shall we talk Pomodoro today? Okay, so once we've gone through this, we'll take a little look at the Pomodoro video. It's like a 2-minute video. Okay, and remember, put your phone away for better marks. Did we talk about why? No, that was my grade 9s I talked about that with. So maybe we'll talk Pomodoro today and we'll put the phone away next day. There's actual science behind these things. So yeah. And then this last one, do your best, forget the rest. Tony Horton. What is it? P90X, which I don't do anymore because now I'm old and feeble. Okay. Students who are able to work hard and feel good about their own best effort, regardless of their grade, are generally going to be the most happy and the most successful. Okay? They are able to celebrate their own successes and they don't beat themselves up over a lower achievement, but actively look for a strategy. If they've seen, oh, I didn't do so well on that, they say, what could I do to grow and improve? And if you don't know, you can always come talk to me. I can give you suggestions. All right, you are encouraged to contact me through Teams or email if you cannot see me in person to ask for help. This is just kind of like do your homework, right? Like don't sit back and not do your homework because that's a good way to fail the course. But I think you guys from what I've seen, have been pretty good. I don't know, I haven't been checking all the time, but Teams, check it regularly. We all know about flex time. Do you all know about the peak program? The peak program runs from 8 until 9:05 every day, Monday to Friday. And from Monday to Thursday, from 3 until 4, and that is in room 207. And there is a teacher there who can help you out with things. There are also volunteer peer tutors who can also help you out with things. Also, if you happen to be good at a particular subject, you might think about becoming a volunteer peer tutor and just go down and talk to one of the people down there and say, what is this? I have no idea how they, choose people to be peer tutors. So just go ask if you're interested in being a tutor, because, sometimes the grade 8s and 9s are in there and you might be able to help them out. Here's our course outline. So right now we are doing math and measurement and matter, okay? I've sort of this is a bit of an older version. This is our first 2 units, okay? Math and measurement and matter. Then we are going to get into atomic structure and periodicity, so the periodic table. Then we will do nomenclature, which is just a big word for naming and formulas, okay, which you should have done in grade 9 and 10. Then we will do the mole, 6.02 times 10 to the 23. We will do reactions, which hopefully you did in grade 10. Yes, at least a little bit. We will be reviewing it, don't worry, okay. Stoichiometry, and that's where we actually start to combine the mole with the reactions. Chemistry is really a course where you need every skill from the unit before in order to do the next unit, yes? So don't throw away your book unless you're sure you know everything in it, yes? When we go to the next unit. Then finally, we will maybe do some bonding and solutions. I think we will probably not get to organic chemistry because I had a hard time getting to organic chemistry even when we didn't have time taken away from the actual class period due to flex. Yes? So we will probably not get to organic chemistry. If you're interested in organic, talk to me. I can give you some resources. You're going to do some labs, blah, blah, blah. I'll let you read that. Marks breakdown, 5% for homework, 10% for quizzes, 10% for labs, and 75% for tests. Grading is cumulative. Yes? It's an academic elective. It's fine. You'll be fine. You'll be fine. Yeah, that's how chemistry is. The reason the labs aren't worth more is that people tend to copy each other's labs, and so I find that I don't want to give too much credit for that. Otherwise, you'd be like, right? Right? I used to have them worth more, and then it would skew some people really high because they were cheaters, and other people would do their own work, and they wouldn't score as high, and I felt bad about that, so now I'm just 10%. And then quizzes, 10%, and homework, 5%. Okay, so at the end of the unit, I find because we don't have as much time, it is hard for me to check homework every day. What will happen is at the end of the unit, when you are writing your test, you're going to give me your book, and I'm going to take a look through it and kind of give you a score on did you do most of the work, okay? You don't have to have done every extra practice. Do you know what I mean? Because if you don't need extra practice, why would you do the extra practice? But if you do need the extra practice, obviously that's a good plan to have, yes? So if you do badly on your test and I notice that you didn't do any of the extra practice, then I can say to you for your next test, please do more extra practice. Yes? Okay, cool. Recommended supplies, obviously pencil sharpener, although we have one of those on every desk. Eraser, blue or black pen, that will be for when we do labs. Okay. Red pen, we will sometimes mark each other's labs because it's actually a good learning experience. You actually learn a lot about how to write a lab from marking someone else's. Highlighters are super useful because you see I highlight things as we go along. Sticky notes, you need some sort of loose leaf paper, but of course we have some free stuff at the back. A ruler is not a bad idea, although we have rulers, so don't worry about that too much, but you will need a scientific calculator. So if you don't have one, you will want to get one. And I think Staples has some for like really cheap. I don't know, at the beginning of the year they had it for like $8, a really good scientific calculator. I'll put a link to the calculator. They're super cheap. Where are they? They look, did I not turn this on again? Is this on? Okay. They look like this. If you're interested, you can come and check it out, but like literally this was $8. Okay, so you're not gonna break the bank doing it. You cannot use your phone because on a test or quiz, you cannot use your phone. And you don't wanna be trying to learn somebody else's calculator while you're doing a test. That's always a little bit stressful. You want your own that you are used to. And that's it. Do we feel course outlined? Excellent. I said we were gonna do something, what was it? Pomodoro, we'll do that another day. Fridays are too short. Okay. I'm like, we need content. We need some content today. So we'll do that Monday maybe, or Tuesday, or whatever day is next week. All right, that's going to get closed because I don't need to have too many things up, and that's going to get open, and that's going to get closed. And we are going to finish up 1.3c, so we'll be on about page 48 or 49, I think. Yep, page 49. One 1.3c. There we are. Oh, that's grade 9. That's not going to help us. Okay. Grade 11. There we go. 1.3c. Okay, here we are. Mixture versus compound. Hang on. What page are we on? That was 48. So this is 49. Oh, yeah, this is. What is the difference? Take a look at those two little pictures there. The one on the left shows a mixture, and the one on the right shows a compound. What is the difference? Tell your partner what you think the difference is between a mixture and a compound. Okay, so what do we think? What's the difference? Yeah, this has two elements combined or bonded. Whereas in this one, the two elements are, yes, they are not bonded, okay, in any way, shape, or form. In this case, the different elements are not bonded to each other. Okay, now in this case it is two elements, but a compound could have two or more if you needed to. Not in this case, but in some other cases, more elements combined together, bonded together, either ionically or covalently. Okay, and then we have our little picture at the bottom. And we wonder why it is safe to put sodium chloride on the fish and chips. That's our NaCl, our table salt. On our fish and chips, but we will not use sodium and chlorine. No, you should not eat chlorine. It would cause huge damage to you. Okay, number one, it is a gas at room temperature. You would breathe it into your lungs. And it was one of the gases that they used to use in like warfare, like World War II, to like, you know, chemical warfare, and it would destroy people's lungs. Very, very bad. Sodium, if it gets in contact with water, or in fact chlorine, it will, if you put it in water, it will start to bubble, and then it will catch on fire, and then might even go bang. And if you're lucky, you might get to see that this year. But you can't tell anyone because we're not supposed to have it anymore. Okay? So, but it's totally safe. But the Burnaby district has just gotten really wound up about it because there was an issue with a student teacher once who did it wrong, like without the safety precautions. And so now they're like, nobody can do it. And I'm like, I've done this experiment for 27 years. It's okay. Excuse me. At any rate, if you put the sodium together with the chlorine, that will also, they are very reactive with one another and you will get an explosion. So the point of the matter is that the properties of a compound are very different from the properties of the separate elements. Oh, it's on the next page. We don't need to write it down. Look, compounds have very different properties to the elements. I have a tendency to do that. I'm always like, oh, I should say this and write it down, and then I've already written it down on the next page. To the elements from which they are made. That's because the atoms are joined together differently. Here's another example. We have some carbon. Can any of you point to some carbon maybe in your possession right now? Yes, there's carbon inside you, that's for sure. How about some pure carbon? Yes, pencil lead, which is not lead at all. It is indeed carbon. It's called graphite. And if you're interested, graphite, if these are all the carbon atoms, they link together to form hexagons. Okay, so you end up with like almost like a beehive kind of structure. What do they call that? Honeycomb structure. And it forms layers. So there are layers of this honeycomb-like structure. How many layers are in this model of graphite? Three layers, okay? And the interesting thing is that these bonds in between the carbon, what kind of bonds are in between the carbon atoms? Talk with your partner. What kind of bonds are between carbon and carbon? carbon is here on your periodic table? So we are to the right-hand side of the staircase. So what type of element is carbon? What types of elements are to the right of that staircase? Starts with an M. Yes. Non-metals. So carbon is a non-metal. It is bonded to another carbon, which is also a non-metal. So what kind of bond do we have? Ionic or covalent? Covalent, okay? When carbon is bonded to carbon, when we have non-metal bonded to non-metal, ooh, that's not gonna work. Non-metal bonded to non-metal, that is a covalent bond. You are, yes you are. You're replacing the oxygen with the, yes, you're replacing the oxygen with the carbon dioxide, exactly. Yeah. So here's our carbon. Oxygen, obviously you need it to breathe and you need it for fire. But if you put, and if you have, actually if you have like a glowing splint and you put it into some pure oxygen, it will actually flare up. So if you provide extra oxygen, fires will get bigger, okay? But if you spray it with carbon dioxide, that will put the fire out because carbon dioxide does not burn. It's already fully oxidized. You don't need to know that word just yet. Back to our graphite, just because I love this so much, okay? So we have covalent bonds here. Covalent bonds are very strong. But in between the layers, these are not covalent bonds. There are weak forces in between the layers of the graphite. Okay, they are between molecules, so we call them intermolecular forces. We'll talk more about that later. Okay, but they're weak. I'll write it down just in case anyone's interested right now. We'll come across it later. Molecular forces, also known as IMFs, because intermolecular forces is really long to write. What does the word inter mean, or the prefix inter? Means between. So intermolecular forces are forces between molecules. And intermolecular forces are weak. So who is it easier to break? Is it easier to break covalent bonds, or is it easier to break intermolecular forces? Intermolecular forces. So within this layer, there are covalent bonds. But between the layers, there are weak intermolecular forces. So let's pretend that this is the tip of my pencil, yes? Okay, here's my tip of my pencil now. When you put your pencil on the paper, let's pretend this is the paper here, there will be intermolecular forces between the graphite and the paper. And actually what will happen is a layer or several layers of the graphite will shear off, and they will stick to the paper and be left behind, and the other layers will be left here. So you're actually shearing off layers of those honeycomb sheets when you're using your pencil, which is kind of cool. Okay, there are some exercises here which we will let you do sometime in the future, not right this second, because I also wanted to talk about algebra with you today. What time are we done at? We are done at 1:45. It's a Friday, so we're done at 1:45. Okay. Oh, it starts at the same, what? How come that, I must have written that down wrong. It's 1:50, and it's 1:50 on regular days too? Okay, it doesn't matter. It doesn't matter. We got time. We got lots of time. Whatever it is, we got lots of time. Okay, some of you, I just want it to all be the same all the time. It messes with my head. One 1.7a. Some of you may find this incredibly basic, and you'll be like, why on earth are we learning this? On the other hand, I have had students who have scored a 5 on the AP exam who have unsuccessfully tried to solve an algebraic equation. So I feel like it is worthwhile to teach it to everyone, especially because the math curriculum no longer stresses basic algebra in the way that it used to, so you guys don't get as much exposure as, say, students 10 years ago, okay? So I find there is a general overall weakness because you don't get that same amount of training, okay? So this is on page 118, page 118. So if you're told to solve an equation for B, if we say isolate B, or if we say solve for B, that means you need to do two things with the letter B. First, okay, so this isn't like 1 and 2 where you can do them in any order, okay? First, you want the letter B to be on the top in the numerator. And then second, you want the B to be all by itself, okay? There are many different ways of doing this, and I'm going to show you 3 of them. You can choose which one you like. When we come to the extra practice, I only show the answer key for the method that I like best because I feel it is the most efficient, okay? So here I have A is equal to B over C, and I want to have B on the top. Except for, guess what? B is already on the top. So do I need to do anything to move it to the top? No, I do not. Now I want to get the B by itself, which means I don't want any other letters on the same side as the B. So who is messing up the side with the B right now? C. Okay. You can move letters diagonally. Okay? You can move letters from one side of the equation to the other side of the equation diagonally. Diagonally up or diagonally down. I never actually used a diagonal arrow because it kind of like cuts off other letters, but if I was to, I would kind of go, okay, so that's going to go up there. Yes? So now I have C times A is equal to B. Is good? So B is on the top. If there's nothing in the bottom, then it's just on the top. Is it by itself? Yes. You are basically done at this point. The only thing that I would ask that you do in addition is to then put the B on the left, because what's going to happen is that when you are doing an equation like this, I'll just show you the sort of thing you might get later on. We have P, V equals NRT. That is a gas equation, okay, and if I wanted to solve for T is already on the top, yes, but I want it by itself. So I could take my N and my R and I could move them diagonally to the other side, which means they're going to be in the denominator. So I'm going to have PV over NR is equal to T. And it seems like I'm done, but what's going to happen is I'm going to have to then put values in, like I'll have a question that gives me a pressure, a volume, a number of moles, and the gas constant. So I'm going to want to be able to write it like this. T is equal to PV over NR, so I can then substitute things in, okay? So my pressure might be 1 atmosphere, my volume might be 20 liters, N is my, what does N stand for? Amount of matter, that is our number of moles, so that might be 0.5 moles, and R is 0.086, 0.08206 liter atmosphere per mole Kelvin. Okay? So that the plugging in becomes easy once you've got it there, but it helps to have the thing you're solving for on the left, because then you can see, oh, I'm plugging 1 atmosphere in for the P and 20 liters in for the V, and I can just put it all in one mathematical line, one mathematical sentence. Okay? You will not be doing equations that complicated this year. You'll be working with density. Density equals mass over volume. Okay, pretty straightforward stuff. So you'll want to make sure that B is on the top. You want to make sure that it is all by itself. And then I'm actually going to add in a third thing. Make sure that it is on the left. Do you know that if you have an equation where you've got something over here on this side of the equal sign and something over here, you can just take the equation and do this? Yes? If you didn't know that, you can do that. Yes? Because it is like saying if I have 6 is equal to 3 times 2, it is also true that 2 times 3 is equal to 6. Yes? So if you have these two things are equal, then these two things are also equal. It's no different. So anytime you need to flip an equation like that, that's totally fine. Okay? So that's one way you can do it. I like the diagonal movement method because it's very efficient. I usually don't actually draw the arrows because that makes it kind of messy, but if it helps you to draw the arrows, then certainly do it. Probably you have seen this method in your math class. Let's see, we had A is equal to B over C. A is equal to B over C. And you might say, okay, I'm going to multiply both sides by C. Yes? And then those will cancel out. Do you see how that does? The end result of that is exactly the same as moving this up diagonally. It just saves you a little step of crossing it out. Okay? The third method, A equals B over C. Third method of doing it is to cross multiply. And if you don't have anything down below, what goes on the bottom? The number 1. So we now have A times C is equal to B times 1. And you'll notice in all cases, no matter which method we used, we ended up with B is equal to C times A, B is equal to C times A, and we ended up with B is equal to A times C. Is it okay that the A and C can be flipped? Yes, because 2 times 3 is equal to 3 times 2. Yes, so it doesn't matter whether you write it B is equal to C times A, or whether you write it as B is equal to A times C, those are the same, because 2 times 3 is equal to 3 times 2. Yes? Okay, so that's example number 1. Blah, blah, blah. So many words, so many steps. Okay, where's example 2? Example 2, let's isolate the C. This one's a little trickier. Okay, so we have A is equal to B over C. And remember, the first thing we want is we want C on the, the top. Is it on the top? No. Could you move it diagonally to the top? Yes, you could. You could say it's here. I could move it up diagonally, and then it will be on the top. So I now have C times A is equal to B. Second thing, we want C by itself. Huh? Yeah, you got to move A. You got to get A out of there. Okay, so we're going to take our A and we're going to move it diagonally to the other side. So where will it be? Will it be on the top or the bottom? It's going to be on the bottom. So you have C is equal to B over A. And then you want C on the left. Is it on the left? Yes, all done. Okay. Super straightforward, but like I said, there have been gaps in people's learning, not your fault. There was COVID, there's the curriculum, which doesn't stress this as much anymore. So if you're not so familiar with this, that's okay. That's why we're doing this. All right, and then finally, example 3. This is the last type. There's only 3 ways you can arrange a 3-variable equation. If we have D is equal to E times F, and we want to solve for E, the first thing you want is you want E on the top. Is it on the top? Yes. Second thing you want is E by itself. Is it by itself? No. Who do you need to move? So move the F. Okay. And where will you move it? Will you move it diagonally up or diagonally down? You have to move it down because it's already in the numerator. It has to go into the denominator on the other side. You cannot do like this and be like, oh, magic, I'm gonna like everything in that line is like all in the, I don't know. You know what I'm saying? And if you get confused, cross multiply and then you'll be fine, okay? So here we go, we got that, we got D over F is equal to E, and then you wanna solve for E, so that's gonna be E is equal to E over F. You guys want to try some problems? Okay, excellent. So you guys are going to do the problems on pages 122, 123. And then you're going to show me number 7 before you leave today so that I know if you know what you're doing. Okay, so pages 122. 123. And while you're working on that, I'll come around and check in on you. 7, you can wake me over and I can check it for you. And then for this one, you're gonna have to make 2 moves. Okay. So first of all, the end has to come up to okay, so the PM equals L, and now you need the PM by itself. The other side of your diagonal. Yes, yes, because it moves okay. So for these ones, it looks like it may be a little bit tricky, so go back and try them again, check your answer. Oh, yes, yes. Oh, yes. Okay, so remember the variables have to move diagonally. You can't have the L move straight over. Yeah, so it's going to move to the bottom. It's going to become a water here in the fraction over here. H equals C. Yeah. Okay, this one's good because you did move the diagonal, right? The water is up, and then this one here.
So tired. It's like visually breaking them. We had to go for a run for gym, and then I had to write a math test. Watch this. Watch this. It's a.
Ooh, spider.
Yeah. Wait, let's do another one. Let's do another one. Oh, yeah, this one. Wait, no, I can't orientate my hands like a normal person. Bert.
You gotta do what you gotta do, Nathan. It's crazy. I just learned that the guy was sitting behind the guy who was sitting behind me in my science class. Apparently he's an IB kid.
I have to wait.
IB? Yeah,
IBM?
Yeah.
Oh, IB, that is a crazy program.
No, yeah, he said that he got out of it.
It's like AP on steroids because you have to take all your classes and you have to do some independent project and sounds like a nightmare to me. The only good thing is that, you know, we had a friend who ended up doing it. They didn't really know what they were getting into. Their kid ended up doing the whole thing. And they said it was an absolute nightmare. But she got to skip first year, so she can finish her degree in 3 years instead of 4 years. And they don't have a lot of money, so they're very, very excited about that. So. Yeah. She's like, yes. Yeah. It is nice. I mean, it's a nice perk.
Crazy.
Okay. Sounds good. Thank you. Yeah.
I haven't, like, my husband did IB when I was interested. But my aunt who did IB, she keeps telling me stories of how she just skipped class and got an A.
Yeah, my mom seemed like the worst student. She met her best friend in the bathroom. But like, I don't.
My husband was a terrible student in high school.
No, like my aunt was like,
It was the olden days. Things were easier back when we were in school. Just so you know, like if they're telling you it's the same, it's not the same. Although IB was always hard. Quizzes are worth 10%, tests are worth like something like 75%. And the rest is like labs. Yeah.
Okay.
So 15 on labs. Yeah. Yeah. Okay, we are starting because class started 2 minutes ago. I don't know where everybody is, but that's okay. We'll keep going. One thing I do want to mention to you. I made a correction to the answer key last day. One of the corrections was a correct correction. The other correction was an incorrect correction. Oh my God. So, on page 58. Okay, books open, page 58. Let's go. Thank you. I love y'all, but you're chatty. Holy mackerel. So last day I said that this one had 2 sig figs. The answer key said 3, but it should be 2. It should be 2 because we have 2 sig figs here And we have 2 sig figs here. Mark, could you close the door for us? There's like weird people in the hallway making lots of noise. I don't know what they're doing, but there's like, ah. Okay. Yes. All right. Secondly, we corrected this, corrected, I put in quotes because it wasn't actually correcting it, to put it into 4 sig figs. But if we look, one of the original numbers that we used was 3 sig figs. So our answer can only have 3 sig figs, okay? There might have been confusion because I think in the answer key, I wrote the first part as having like 4 digits, but that's because I was keeping an extra digit so I didn't end up with a rounding error. Yes? Okay, so this should have 3 sig figs because of that number right there. All right, were there any questions from either 5.3a or 5.3b? Going once, going twice, going 3 times. Sold. You can ask me later. Today's a short day, so we're going to just keep plowing along. We're not going to do this one. Oh, actually, we are going to talk about this because you should be aware that at the very front of your booklet, 5.0a, there is an overall sort of master chart about all the conversions. Yes? So, we have so far done all of this. Yes? We can convert between atoms and molecules. We can convert between atoms and molecules. We can convert between particles and moles. We can convert between moles and grams. And we just added in using molarity to convert between moles and the volume of a solution. How did we feel about doing that? That was okay. What does the word molarity mean? Molarity, it means the concentration in what? What unit? Moles per liter. How else can you write moles per liter? Yes, a capital M means moles per liter. How do you pronounce that capital M? So if I was to say that unit, if I had something and it said 1.0 M, I would read that as 1.0 molar, like your tooth, okay? Molar. What are 2 ways you can represent, if I wanted to say the concentration of potassium nitrate? What are 2 ways that I could write that? I could use square brackets, so I could say square brackets KNO3. And when I use square brackets, that specifically means not just any old concentration, you can't do it in grams per mole. This specifically means the molar concentration, so in moles per liter. So that's what those square brackets mean. That's the thing we tend to use most often because it is a right pain in the arse to type the other way of doing it, which is, what's the other way? Yes. C and then the subscript KNO3, because you can imagine we have a subscript and then we have another subscript and things get really small and ugly and I just can't deal with it. So, and mostly people don't use this nearly as often as they use the square brackets, okay? So if you're calculating that, if you know the moles and you know the liters, it's pretty easy to calculate the molarity, yes? What if I gave you grams and liters? Would you be able to calculate the molarity? Yes, you just convert from grams to moles and then do the division. Okay, excellent. So yeah, that's about it. And we all know how to convert between milliliters and liters quickly. Move your decimal place 3 places, okay? Milliliters to liters, move the decimal 3 places. Excellent. Oh, and I'm still recording from my other block. That's exciting. Oh well, I'll have to actually process it and split it in half. That'll be fun. I don't like doing that because it eats up like so much like memory on my computer when I'm doing it. It's like so slow and nasty. So maybe what I'm going to do is I'm going to press stop.